So imagine you are standing at the base of a planned 40-story high-rise. You got all your materials, your crews are ready, you have the permit.
Right. Everything is set.
Exactly.
Yeah.
The only thing standing between you and actually breaking ground is, well, the schedule.
Which is usually a massive bottleneck.
Oh, a total nightmare. I mean, orchestrating the thousands of interdependent steps to build that tower safely, that typically takes a team of highly trained human planners about 20 grueling hours.
At least 20 hours.
Right. But what if an algorithm could generate a mathematically superior, safer, and faster build sequence in just 2.3 hours?
I mean, that changes the entire economic foundation of how we build the world around us. And, it's not some hypothetical scenario anymore.
It's really not.
No, that is a documented reality from an academic study that analyzed 15 actual real-world construction projects.
Wow. Well, welcome to today's deep dive. We are looking at a massive stack of sources today.
We really are.
Yeah, ranging from deep research on generative AI for construction sequencing to these huge industry-wide reports from Autodesk and Bluebeam.
Which is super relevant right now.
Absolutely, because our mission today is to analyze the construction and engineering landscape from our current vantage point in mid-2026.
Right. Because things have shifted so much recently.
They have. We're exploring how artificial intelligence has finally, moved past that initial hype phase and is fundamentally rewriting the mechanics of our physical world.
Yes.
And we're also going to dissect the intense psychological friction and, frankly, the massive legal liabilities that are actively holding this industry back.
Yeah, well, to give you a clear baseline of where we sit today, we really have to look at the latest 2026 Autodesk survey.
Okay, what are they seeing?
Well, the data presents this really fascinating paradox. Only about 32% of construction leaders feel they have actually achieved their internal AI goals.
Oh, wow. That's pretty low.
It is. Yet, the technology itself has officially crossed the threshold. Like, it is no longer categorized as some shiny future trend.
It's just the reality now.
Exactly. It's the absolute industry baseline. The consensus among all our sources is pretty unanimous. Architectural and engineering firms that fail to adapt to this new baseline, they are actively risking their survival against competitors who can just deliver projects with unprecedented speed and predictability.
Okay, let's unpack this. Because to understand how AI is changing something as intensely physical as, say, pouring concrete or erecting structural steel.
Routing, plumbing, yeah.
Right, routing plumbing. We first have to understand the language computers use to even perceive a building in the first place. I mean, you can't optimize what you can't see, right?
No, you can't. And we can actually trace that evolution through a brilliant paper from the Kielce University of Technology in our stack.
Oh, yeah, that paper's great.
It is. They break down the history of digital construction, specifically building information modeling, or BIM, into these distinct eras.
Okay, break those down for us.
So the first era was that transition back in the 1980s and 90s. We moved from flat 2D paper drawings to 3D computer-aided design, CAD.
Right. So for the first time, architects were essentially sculpting buildings digitally.
Exactly. But the issue was those early 3D models were basically digital islands.
What do you mean by digital islands?
Well, the architect had a beautiful 3D model, but the structural engineer had a completely separate one. They didn't talk to each other.
Got it.
Which naturally birthed the second era in the 2000s, right?
Yeah.
The era of federated models. This is where the industry started slamming those digital islands together.
So you take the architect's shell, overlay the engineer's steel skeleton, and then bring in the mechanical contractor's ductwork just to see where they crash into each other.
Exactly. You're looking for clashes.
But I imagine the friction there was software compatibility, right? Like, if I'm speaking French and you're speaking Japanese, putting us in the same room doesn't mean we can suddenly collaborate.
That was the exact bottleneck. And that led to the third era, starting around 2012. This was the big push for open BIM and open standards.
Right, specifically that universal file format called IFC.
Yes, industry foundation classes. The whole goal was pure interoperability. So if an HVAC designer uses one software suite, the data should flow flawlessly into the architect's entirely different software suite.
Okay. And that timeline brings us right up to the debate raging in the industry today. Are we officially crossing into the fourth era, the AI era?
That's the big question.
Because when I look at this timeline, I have to push back a little on the premise here.
Okay, go for it.
I mean, it is one thing to have a beautifully structured, fully interoperable digital blueprint But it is another thing entirely to hand that pristine blueprint to an algorithmic intelligence.
Right.
Like, how does an AI know if a perfect digital plan actually survives contact with the physical reality of a job site?
The real world is messy.
Exactly, a site filled with sudden rainstorms, unpredictable mud, and just, inevitable human error.
Well, you've hit on the defining friction point of 2026. Hamid Chaudhry from the spatial computing company Cupix actually tackles this directly in the Autodesk report.
Oh, right. He introduces that concept.
Yes, a critical concept called spatial intelligence.
Yeah.
So if you think about the AI you interact with daily, like the large language models writing emails or summarizing reports, they are trained almost exclusively on textual data.
Words, spreadsheets, financial documents, that kind of thing.
Exactly. So an AI might analyze a massive spreadsheet of construction tasks and optimize a schedule that looks mathematically flawless on a two-dimensional screen.
But it lacks situational awareness
Exactly. It might casually schedule a massive crane to operate in a physical space where, say, a fresh concrete wall was poured just hours prior.
because it doesn't physically know the wall is there.
It has no idea.
It's like a submarine captain trying to navigate a coral reef using only raw SOMAR ping data without ever actually looking through a periscope to see the real environment.
Oh, that is a perfect analogy. And the periscope in this case is spatial grounding.
Okay, how does that work in practice?
Well, by continuously feeding the AI visual and dimensional data from the actual job site, we're talking daily automated drone flights, laser LiDAR scans, 360-degree hard-at cameras.
So it's constantly absorbing the site visually.
Right, that's how the AI achieves spatial intelligence. It anchors its digital predictions to the physical, constantly evolving reality of the site. It moves from merely predicting a schedule to actively verifying the environment.
Here's where it gets really interesting, because once you give an AI that spatial periscope and you let it take the wheel on project planning, the real-world results become, frankly, astronomical.
They really do.
Let's dig into the mechanics of GenSec AI. That's the generative AI for construction sequencing framework we mentioned at the top of the show.
Yeah, this academic paper is where we officially graduate from theoretical potential to hard, undeniable numbers. GenSec AI doesn't just rely on a single algorithm. It orchestrates three distinct branches of machine learning to simulate and schedule a build.
We really need to break those three components down, because the actual how of this technology is fascinating.
It is. So the first component utilizes vision transformers.
Okay, what do those do?
This provides the spatial intelligence we just discussed. A vision transformer ingests the 3D building model and literally chops it up into a grid of 3D volumetric patches.
Huh.
Then it analyzes the relationships between those patches. So it learns that a highly intricate web of plumbing physically threads through a specific configuration of structural steel.
Wow, okay. So it's essentially developing a form of object permanence and geometric logic. It understands that two solid objects cannot occupy the exact same physical coordinates.
Exactly. And once it maps that geometry, it brings in the second layer, large language models, or LLMs.
Right, the text-based ones.
Yeah, and this layer handles the rules of physics, safety, and logic. A human project manager can input a plain English constraint, such as the concrete foundation must cure for a minimum of 14 days before any structural steel activities commence.
So you just talk to it normally.
Right. And the LLM translates that natural language into a hard, immutable Boolean logic gate that the system cannot override.
That's incredible. And the third piece is the engine that actually generates the timeline, right? Deep reinforcement learning.
Yes. This is the core optimizer. Deep reinforcement learning treats the construction site like a staggeringly complex, high-dimensional chessboard.
How many moves ahead is it thinking?
Millions. The AI runs millions of simulated construction sequences. It explores every possible consequence of moving a crew here or delaying a material delivery there.
So it's learning from its own mistakes in the simulation.
Exactly. It gets mathematically rewarded for sequences that finish faster, utilize resources more efficiently, and maintain strict safety parameters. Through millions of trial and error simulations, it learns the absolute optimal path to build the structure.
When you look at the results from testing this across those 15 real-world projects, the numbers are just wild.
They're hard to believe at first.
Yeah, I mean, they documented a 23% reduction in overall project duration. If you're listening to this and you manage a major commercial development, shaving nearly a quarter off your timeline is tens of millions of dollars in saved carrying costs.
Easily.
Furthermore, they saw a 31% improvement in resource utilization.
meaning you don't have expensive cranes sitting idle or labor crews just waiting around for material.
Exactly. And on top of all that, an 18% jump in safety scores.
We also really have to revisit that initial speed metric we talked about. Generating these highly optimized sequences took the GenSec AI system roughly 2.3 hours.
Which is absurd.
Right. Traditional human planners using conventional legacy software take 15 to 20 hours to perform the exact same task.
Yeah.
And frankly, human brains simply cannot calculate enough permutations to yield schedules this efficient.
And this level of integration isn't just happening in closed academic testing environments either.
No, it's out in the wild.
Yeah, the University of Texas at Arlington published a study where they monitored a 9-month mid-rise construction project right in Dallas-Fort Worth. They deployed what they call an integrated 4D and 5D digital twin.
I should probably clarify the industry terminology here real quick.
Yeah, go ahead.
So a standard 3D model is just geometry. When you add the dimension of time, so the schedule, it becomes a 4D model.
Okay.
And when you integrate the dimension of costs and materials, it becomes a 5D model.
Right. So on this Dallas-Fort Worth project, they utilized natural language processing, or NLP. They fed messy, totally unstructured PDF design specifications into the system, and the NLP automatically parsed the text and mapped it to standardized cost codes.
Which saves so much manual entry.
Oh, absolutely. Then they deployed computer vision algorithms to analyze daily photos taken from the job site, automatically tracking the physical progress of the build against that 5D model.
The economic impact of automating those specific workflows is staggering. The study reported a 43% drop in the labor required simply for cost estimating.
Almost half the labor.
Right. And by having a perfect real-time grasp on the schedule, they reduced costly overtime hours by 6%, and the entire mid-rise project finished perfectly on time at exactly 128 days.
That's unheard of. Let's also look at how this changes the day-to-day grind for a specialist. We have a great case study from Equins, an MEP contractor.
Right. MEP stands for mechanical, electrical, and plumbing.
Historically, when you run a clash detection scan to see if a pipe accidentally intersects with an electrical conduit in the digital model, the legacy software generates literally hundreds of false positives.
So a wall of alerts.
Yeah, and a human engineer has to sit at a desk and manually verify every single one. Equins deployed AI to filter out the noise.
Well, it's important to understand how the AI filters that noise, too. It's trained on thousands of historical, human-resolved clashes.
So it learns from past human decisions.
Exactly. It learns the spatial patterns to differentiate between a harmless, minor overlap of flexible insulation versus a critical error where, say, a rigid water main intersects a load-bearing concrete pillar.
So it's smart enough to know what actually matters.
Right. It acts like an immune system. It ignores the common cold so it can attack a severe virus. For Equins, this reduced their clash resolution time by a massive 70%.
Which frees up the human engineer to focus on complex problem solving rather than mindless data sorting.
Exactly.
But, this brings us to a massive causal disconnect in our sources.
Okay, what's that?
Well, if this technology reduces project times by 23%, cuts clash resolution by 70%, and saves millions of dollars, you would logically assume every firm on Earth is using it today.
But they aren't.
They aren't. Data from Dan Cumberland Labs shows that while 78% of engineering firms believe AI will positively impact the industry, only 27% of professionals are actually using it.
The adoption gap. If the tools are this powerful, why are they just sitting on the shelf?
Because 90% of the barriers choking this industry right now are organizational and financial, not technical. Let's start with the financial reality, which is creating a brutal squeeze on small firms. The enterprise-grade AI tools required to achieve these massive benefits, they are prohibitively expensive.
They really are.
Take Microsoft 365 Copilot, for example. Deploying that at an enterprise level requires a 300-user minimum commitment. That can cost a firm $108,000 annually just for the licensing.
A 20-person boutique architectural firm simply cannot absorb that overhead. And the industry data totally reflects this growing chasm.
What does the data say?
Well, if you analyze architectural and engineering job postings, 11.1% of the largest, most capitalized firms explicitly mention AI skills. For the smallest firms, it's a meager 1.3%.
Yeah.
Smaller outfits lack the budget, they lack the specialized IT talent to integrate the tools, and the major vendors aren't scaling solutions down for their size yet.
But even if a firm has the budget, they run into the paper problem.
Oh, this is wild.
It is. This statistic from a 2025 BlueBeam survey of over 1,000 professionals is mind-blowing. 52% of the architecture, engineering, and construction industry still relies on physical paper during the design and build phases.
Over half the industry is operating analog in an algorithmic era.
Yes.
Hey,
You cannot run a cutting-edge vision transformer or a deep reinforcement learning simulation on a stack of coffee-stained, dog-eared blueprints sitting in a site trailer.
no, you definitely cannot.
If an engineer has to manually type handwritten field notes into a database, the risk of a typo throws off the entire algorithmic sequence. Data fragmentation just starves the AI.
And, that manual data entry creates a direct pipeline to the psychological barriers we're seeing.
So.
When workers are forced to manually clean up data just to feed an algorithm they don't fully understand, it breeds deep resentment.
Which brings us to the most human element of our deep dive. Why are highly educated professionals, people who know this tech works and have access to it, actively resisting it?
What's fascinating here is a phenomenon researchers are calling AI angst. A recent study published in the Harvard Business Review found that a staggering 80% of employees experience distinct anxiety regarding AI in the workplace.
80%.
Yeah. They harbor intense fears that relying on an algorithm will make them appear incompetent to their peers, or ultimately render their hard-earned expertise totally obsolete.
Well, think about it. If you're a master scheduler, your entire professional identity is built on your nuanced judgment, your experience, and your ability to orchestrate chaos.
Right.
If a machine can do your life's work perfectly in 2 hours, that feels like a real existential threat.
Absolutely. And that psychological threat leads to a behavior the HBR study identifies as anxious compliance.
Anxious compliance.
Yes. Because executive management is mandating the use of AI to stay competitive, employees technically use the tools, but they use them defensively, out of fear rather than genuine curiosity.
How about give me an example of that?
So they might use an LLM to draft a simple email just to check a box for management, but they completely refuse to trust it with core structural workflows.
And, their lack of trust is entirely justified when you look at the consequences.
Well, for sure.
Because the anxiety isn't just about bruised egos, it's about severe, life-altering legal and physical safety. If an algorithm sequences a high-rise build or calculates a load-bearing tolerance, and a catastrophic failure occurs if a balcony literally collapses, who goes to prison?
Well, you cannot put a deep reinforcement learning algorithm in handcuffs.
Exactly.
And the legal frameworks governing the physical world are incredibly unforgiving. Both the National Society of Professional Engineers and the American Society of Civil Engineers have drawn a very hard line in the sand.
What's the rule?
A human engineer remains personally, legally, and ethically responsible for all AI-assisted work. The software vendor absorbs zero liability. Furthermore, the European Union's AI Act explicitly classifies the use of artificial intelligence in construction and critical infrastructure as high risk, mandating rigorous human conformity assessments.
Which creates a massive, very human vulnerability known as automation bias.
Right.
Because large language models are designed to be incredibly articulate, they don't just provide an answer. They provide a highly confident, beautifully formatted, grammatically perfect answer.
The articulate hallucination.
Yes, exactly.
Hmm.
If you have a tool that works flawlessly 99 times out of 100, your brain naturally gets lazy on the 100th time.
It's just human nature.
If an AI hallucinates a critical detail, say it makes a mathematically false assumption about the sheer tolerance of a specific grade of steel, it presents that fatal error with absolute, unwavering certainty.
Which is terrifying.
Right, because if you are a tired structural engineer who has been reviewing compliance documents for 9 hours, it is terrifyingly easy to skim that confident output, nod your head, and stamp your legal seal of approval on a disaster.
This raises an important question then. How do we safely harness this monumental computational power if it operates as a black box that occasionally fabricates reality, yet holds absolutely no legal liability?
Well, the Basewise article in our stack provides a highly practical framework to solve this. They advocate for a protocol called human in the loop.
Okay.
But they stress this cannot just be a temporary Band-Aid while the tech improves. It must be a deliberate, permanent architectural design choice for how firms operate.
Meaning AI must be structurally treated as a highly capable, incredibly fast drafter. It generates the initial proposal, but it's explicitly barred from being the final decision maker.
Right.
Basewise emphasizes that in the least forgiving sectors of the business, financial forecasting, regulatory compliance, structural safety controls, there is zero margin for hallucination.
So the required workflow is draft, verify, revise. Every single normative claim the AI generates must be aggressively audited.
Show your work.
Exactly. If the AI spits out a sequence stating a retaining wall must be 3 feet thick, that output must include a direct auditable hyperlink tracing back to the original local building code or structural engineering source document.
If the AI cannot provide the source, the human cannot accept the output.
So what does this all mean? When we look at the raw speed of GenSiC AI, the massive cost savings of digital twins juxtaposed against the paralyzing AI angst and the strict liability laws, it becomes clear that AI is not replacing the builder.
Not at all. It is actively forcing the builder to elevate their role. If you are listening to this and you manage a team, your job is transforming.
How so?
You are moving from being a brute force processor of raw information, spending 20 tedious hours dragging blocks around a spreadsheet to build a schedule, to becoming a master editor and a strategic interrogator of information.
Yes. You shift your finite human energy from creating the baseline to interrogating the baseline. The algorithm accelerates the mechanical process, but the human remains the sole owner of acceptance and risk.
It is a massive paradigm shift in how we construct our world.
It really is. Well, thank you for joining us on this deep dive. To summarize our findings from mid-2026, AI has irrevocably transformed the mechanics of the architecture, engineering, and construction industries. Generative sequencing, predictive clash detection, and spatial intelligence are yielding efficiency gains that were mathematically impossible a decade ago.
Yeah, absolutely impossible.
But the industry's ultimate success, whether we universally embrace this fourth era of BIM, depends entirely on eliminating data fragmentation, digitizing that 52% of paper, and maintaining rigorous, legally sound human oversight.
I want to leave you with a final thought to ponder, building on our discussion of liability and algorithmic hallucinations.
Oh, definitely.
As the field of explainable AI or XAI continues to mature, we will soon interact with algorithms that don't just spit out a confident answer, but actively show their complex mathematical proofs.
Right, they show their work completely.
Exactly. We are approaching a horizon where algorithms will consistently generate structural designs with a mathematically verified error rate lower than any human brain could ever hope to achieve.
Which is an incredible thought.
It is. But when that day inevitably arrives, when the machine's math is undeniably perfect, fully transparent, and demonstrably safer than human intuition, will our legal frameworks be forced to radically adapt?
That's a great question.
Will we eventually reach a tipping point in society where an artificial intelligence algorithm itself is legally required to hold and defend a professional engineering license?
Imagine that reality. The pristine digital blueprint, finally navigating the chaos of the mud on its own legal authority. It is definitely something to think about. Until next time, keep diving deep.